this kind of Rube Goldberg thing just does this. It glops it all off into this kind of sluice gate, and it just sends it away. They take about 40 truckloads of murk out to a landfill every day.
Wow.
40. Well, it's the sheer volume of everything, like 300 million gallons a day. They had, you know, this kind of channelized area that was the 1950s sewage settling ponds. It was like the size of about a dozen Olympic swimming pools, and they said, yeah, this would handle 37 minutes of waste in the event of, you know, they use it now for backup. If the current system gets screwed up, they got 37 million, you know, 37 minutes worth right there. So I guess the idea is, you don't need to put your water down there if it's gently used water, which is, we'll talk more about that. And this is how much we use. This is in liters, but it's for reference purposes. It is about 150 gallons per person per day. In Los Angeles, according to the latest DWP, it's 123 gallons per person per day. So we're doing better than the rest of the country due to conservation efforts. But we have a long way to go. In Europe, for example, it's around 75 gallons per person per day. England is 40. China is 20 gallons per person per day. And down at the very bottom, Mozambique, that's an average of 1 gallon per person per day, which is the minimum the UN claims is the minimum required to establish like very basic sanitary requirements and sort of sustaining life. Basically is 5 gallons per person per day. So that goes, about half of that, what we use in America, goes to landscape. So of the 150, about 75 gallons is going into your yard, the other 75 is in your home. It kind of breaks down, you know, so people are astonished to find out they use, or that we use that much water. But it's, you know, when you start breaking it down, well, you know, 20 gallons for toilets, 20 gallons for laundry, 40 gallons for showers, etc. It all sort of adds up. And then we have people like this. We can't see it very well, but this is a water bill that someone sent me. They actually called me up and wanted a gray water system because their bills were $990. Their address is up on Mulholland Drive, appropriately enough. And that's their daily average. They use 3,961 gallons of water a day. I didn't go out there. I assume it's a combination of overwatering, leaky swimming pools, bad irrigation, you know, leaky irrigation systems, etc. Here's one way that we use that much water is just blasting our lawns, which people shouldn't even be having, with water, so it's all running off down the street. And then you have people like this, my neighbor, watering her driveway. The driveway is going to grow. And the question then is, well, where is all this water coming from? Well, this is one source. This is Owens Lake, now Owens Dry Lake. This is the, if you've seen the movie Chinatown, this is the original source of William Mulholland's water. That's a big place, the Sierra Nevadas. Another source is the Colorado River. Here's the Grand Canyon. And this is the end of the Colorado River. The water no longer makes it to the Sea of Cortez. It used to flow all the way down through Mexico to the Sea of Cortez. It does not make it anymore. There are too many straws dipping into the soda. So, and there's a lot of politics surrounding the Colorado River, you know, how that water is divvied up. But it's pretty tragic how that happens. The other thing I'm going to mention real quick is that the Sierra Nevada mountains have a snowpack. Currently it's sort of year-round, and it lasts, it holds many feet of snow. It acts as a bank of water that's kind of stored throughout the year, and it's slowly dispensed throughout the year as the snowpack melts. In 30 to 50 years, that snowpack will not be there year-round, and it's going to dramatically alter the way water is is stored, unfortunately, and delivered, because it will all run off in the early summer or midsummer. It will overwhelm the current, the existing infrastructure, the reservoirs that hold that water, and then there won't be any more trickling down after that. So if you think water is, the whole dynamics of how water is how we think of it is going to start to get rearranged in the state of California. Currently, it gets down to, this is the California aqueduct that brings water from the other main source of water is the San Joaquin Sacramento River Bay Delta, 450 miles north of San Francisco, which is it's essentially all runoff from the Sierra Nevadas. That water is transported 450 miles across the state to the California aqueduct system. But eventually it hits the Tehachapi Mountains. This is the Grapevine, the pumping station. The water moves south, it hits the Grapevine, it has to go up 3,600 feet over those mountains to get to LA. This particular pump moves 2 million gallons of water a minute up 500 feet, and then from there there's 6 more pumps. But that series of pumps uses a tremendous amount of energy. Because, if you think of carrying a gallon of water up 3,000 feet, it's doing that millions of times a day. This one pumping station uses the equivalent electricity of a nuclear power plant running 24 hours a day.
Whoa. I think that incorporates some hydro.
They do have hydroelectric on the downside. This is sort of a hydroelectric station in reverse. It's using electricity to move water up. Then on the other side, they recapture some of it, but it's not efficient. It's a very inefficient system. And then the important statistic here is that in the state of California, 19% of the electricity in the entire state goes to moving and treating water and wastewater.
Wow.
So it's just the whole energy, the water infrastructure is very tied in with electricity, with the power grid, and vice versa. Actually, it takes a lot of water to make power, and vice versa. But 19%. That also includes sewage and the treatment facilities. This is you probably driven past this on the 5 freeway. This is where William Mulholland stood in the I think early 20th century and said the 5 words that are most responsible for creating Los Angeles. There it is. Take it. So, and with that, Los Angeles was born in its current form.
That's been said many times.
Should.
Your sister.
What's that?
I said, yeah, those are famous words that have been used many times.
Yeah, your sister. I read that there's a this idea that in the East Coast, wasting water is to sort of let it go down the drain or something like that. On the West Coast, wasting water is to let the river go past you without taking it. So anyway, this is part of the Los Angeles aqueduct system, which gets water from the Sierra Nevadas. That was actually a very interesting engineering feat because when it was built, it did not use any pumps. It was all siphons and stuff like that. It was all downhill, so they managed to get the water down here. However, that's the Owens Dry Lake, which doesn't have much water left in it anymore. And Mono Lake is the other one near there.
And now DWP is trying to get out of mitigating the rest of
there's
the dust.
a huge. I didn't include the slide, but I have a slide of the dust storms coming up. And then there's another very interesting thing about the dust storms. Since I'm on the subject, there was a lecture I saw at JPL a couple weeks ago about how the single most factor that's causing the snow to melt prematurely is dust. So dust kind of migrates across from the Owens Valley, lands on the snow, which the darkness of the dust makes the snow melt. And he talked about going out there for a day to do this study, and they wiped off this sort of gray grit off the snow, and then they went out and did their research. They came back an hour later, or like 6 hours later, and that one area that was white snow was 6 inches higher than all the snow around it, melted down 6 inches, except this one area where it was like reflective. Yeah.
This is the jet
So
propulsion
there's
lab?
this sort of these loops that just reinforce each other.
This is a lecture at the Jet Propulsion Lab?
They do this whole series of lectures. I'd never been there before. They're great. There's like, go to their website. They've got about 8 different lectures. And they're like, some of them were like life on Earth, but this was all about sort of atmospheric conditions and what JPL has been doing to monitor and study this sort of stuff. This is something I've been studying for, this should be round, it's a little distorted. The Earth, this is what would happen if you were to take all the water on Earth, roll it up into a ball, and put it in the middle of Colorado. And this ball of water represents all the water. So it's all the lakes, rivers, oceans, polar ice caps, groundwater, atmospheric water, etc. It would be a sphere 860 miles in diameter, which is, I studied this for so long trying to figure out how that could possibly be true. But it is true. It's on like the National Geographic website. There's more information about it if you're interested in looking it up. Of all the water that's in the world, about 1% of that is sort of available, is fresh water that's available to man. Basically, the rest of it is 96% is ocean salt water. 3% is sort of polar ice caps that's a little bit unavailable. So 1% is lakes, rivers, and maybe another 1% is groundwater. So there's not that much. So and getting to be less every time, every minute it would seem. So the kid in the bathtub was the first idea I wanted to tell you that's sort of important. This is the second one. This is what the tree thinks. The tree needs water, but it does not need drinking water. It does not need, you don't need to irrigate trees with purified, filtered, sterilized drinking water that comes from 450 miles away.
This is what the tree is thinking. I do not need drinking water.
Exactly. Yeah, trees are perfectly okay with slightly, gently used water for the house. Which brings us to gray water. So basically the definition is, the legal definition is you cannot, it's all water generated except for toilet water, which is black water, and also kitchen sink water is technically considered black water. It generally is about closer to 80% of water used in the home if you were to start catching every, it kind of varies by household. But because so many toilets now are much more efficient, it's now a greater percentage of the water used in the home is gray water. We try to avoid kitchen sink water. People always say like, oh, I'm really responsible. I don't put anything down there. But in reality, they probably do. Like every night, if you clean the butter off, that's going to be oil that ends up in your garden. So the most common use, for me, the best and highest use of gray water is landscape irrigation. It can also be used for toilet flushing. We can talk more. If you are interested in this stuff, I don't have time to get into all that, but feel free to grab me at some point later on in the day, and I'll tell you everything I know about reusing gray water for toilets. One thing about gray water, we'll talk more about this, is if you store it in a tank, it starts to grow bacteria.
And then you can't use it to water your toilets.
Yeah, exactly. So that means a toilet tank too. So if you put gray water in a toilet tank and then go on vacation, you come back a few weeks, it's going to smell very bad. You'll get anaerobic bacteria growth, so that water will turn septic. But there are very few downsides to gray water. You'll save water because if you're reusing your water, you're basically using it twice, once in the house and once out in the landscape. So your trees are not using water that comes from the Bay Delta in Northern California. They're using water that came right out of your house. That will save you money. A lot of these systems can save $40 to $60 to $100 per month if you start recapturing all that money, all that water. Saving that water also reduces your energy footprint, so you are not responsible for having that water transported all the way across and over the mountains. The other thing, it reduces load on sewage and septic systems. People with septic tanks love gray water because a lot of them have these systems that need to be serviced, flushed out, etc. I get calls from people in Mount Washington and Malibu, places like that, where they're trying to keep their septic system, keep excess water out of that. So if you can keep the water on the surface of the soil where the plants can evapotranspire it instead of having to put it into a septic tank, that's much better. And then in terms of just using your sewage, that 300 million gallons a day doesn't have to go all the way down to LAX, to the Hyperion plant, where it is then treated, processed, evaporated, they put it through centrifuges, all kinds of stuff happens in there. So it saves, reduces your energy footprint that way too. The other thing that happens with that water that goes out, after it goes to a Hyperion treatment plant, it's pumped out of a 12-foot diameter pipe that's 5 miles long. This goes out into the center of the Santa Monica Bay. What they do there is secondary treatment, so it still has a lot of chemicals in it. It's not potable quality. It's got phosphorus and nitrogen, which are components in soap. When phosphorus and nitrogen go into the ocean, they act as they're fertilizer. So they're very good to use on your soil. But they're not good to use on. They're not good to use in the ocean because for the same reason that they're fertilizer, they'll cause algae blooms in oceans, rivers, lakes, etc., which can then cause these big fish die-offs.
So that Salton Sea?
The Salton Sea is mainly agricultural runoff. So yeah, it's the same thing though. It's like all the chemicals from that, all that factory farming around there just end up leaching into the Salton Sea. It's just, it's a trip. If anyone ever goes down to Michael?
I know I took a class down there. The Chevron factory is down there. There's a place I took a class that they're reusing the water that comes from the Hyperion plant for.
There's a farm.
It's a government ran. I think it's in El Segundo, and they process a huge amount of water that they reuse.
How do they get the water out? They pump it out there.
I think it comes from a Hyperion plant, and it gets pumped down to this plant where they purify the water and they use it for irrigation.
Yeah,
they are using some of the Hyperion water for state use.
Yeah, Hyperion only does secondary treatment, so it's.
Then they get processed to this other place.
In fact, they had all the landscaping at Hyperion was done with not gray water, but even a higher degree of recycled, the purple type water.
Yeah.
But in order to get it there, they piped it to that other facility you're talking about.
I forget the name of it.
Several miles away.
It's a huge facility. They filter out a lot of water.
West Basin.
Huh?
West Basin.
Is that what it is? I don't remember.
Yeah. Treatment plant.
Rosecrans?
Yep.
PCH?
Yeah.
Using those sort of industrial recycled water systems are great, but in order to use them, you need to run parallel, a set of parallel pipes through the city streets. So, it's not easy to do that often. So if you happen to have a golf course that's near a sewage plant, then they can get it to work out. But in general,
I think there's one right there.
Yeah,
right. It's over there.
But it doesn't always work out.
And that water is really salty. That water is really salty, and so it's hard to do drip with it because it clogs up the emitters. That purple pipe water. Sorry.
You good? Did you have something to contribute? No. Okay. Okay. So going on with the benefits of gray water is it also recharges local groundwater. Even if you're not using it for plants, it's still better to put that water into the water table around your house instead of draining it out into the ocean. It'll just sort of contribute to keeping basically like flora growth for all around your house or blocks away. And also, currently 11% of the DWP water does come from local sources. So there are pumping plants in the valley where they're actually getting groundwater out and using it. 88% comes from sources 250 to 450 miles away in the Colorado River and all that stuff. 11% is recycled water, or is local sourced water, groundwater, and 1% is the recycled purple water. Sustains a beautiful and bountiful garden, of course, use it for watering plants. And the final thing is increasing your awareness. When you start to recycle your water, recapture it and reuse it, you start to pay a lot more attention to your patterns of consumption and disposal. So you start to think about what products you're using, what's going down your drain, and how much water you're using, which I think is quite a benefit. At my house we have about 14 fruit trees. I have 3 peach trees, plum tree, avocados, rosebuds, kumquats, grapefruits, oranges, lemons, figs, guava. All of them are irrigated with gray water. Very occasionally in the summer I'll put a hose on it, but almost all of that is just free water. And we're using that. Those trees they'll start shading our house, keep it cool in the summer. The evapotranspiration from the leaves of those trees, which is basically the trees sweating water, will create a cooler microclimate around our house too. So there's just a bunch of benefits. I feel like our house, usually people's houses are these malevolent presences that just sit on the landscape and consume resources, and you put out the garbage cans and everything gets taken away and it goes down to the sewer. If you can start to recycle your things, get your water recycled, start growing local vegetables and all that stuff, then it becomes a positive contribution to the environment. I'm going to start getting into more like nuts and bolts stuff now. There are certain situations when gray water does not really work out. One is inaccessible pipes. If you have a concrete slab on grade house and the pipes all go down under that slab, you're going to have a very hard time getting that gray water. The typical bathroom, there's a toilet, a sink, and a shower, and they all come together into one 3-inch pipe, and that pipe goes to the sewer. If that bathroom's on the second story, that's also difficult because you have to knock out the ceiling below to isolate the gray water line, and then run that line parallel down. It's called dual plumbing. So that can be, it's not impossible, but it's a much more elaborate intervention in someone's house. But luckily in LA, there's a lot of craftsman bungalows, a lot of hills, a lot of crawl spaces. And then the other thing is with washing machines, you can always get the gray water because it comes out a pipe on the back of the machine. Sometimes you'll have a situation where there's no, people will call me up and say, I want to use gray water, but they live in an apartment, for example, or they live in a place where there's no landscape. It's just such a small lot. There are soil permeability issues where you might have in Malibu or some places like that where there's a lot of the rock is close to surface, very little soil. Sometimes poor cost-benefit ratio. I mentioned this, we'll talk more about this, but there's this kind of McMansion thing that can sometimes happen where someone will have 8 bathrooms. Like the guy who called me up and was like, well, we're using what it was 3,900 gallons a day. I didn't bother to go out there because he could have probably recaptured about 100 gallons a day in gray water. So then his water bill would be 3,800 gallons a day. And he had much deeper problems.